So far we've talked about the normal distribution, the standard normal distribution, and how to find probabilities and areas under the curve and pieces of raw data if needed. So in this section, we're going to talk about how do we assess normality. So most of the questions we've seen so far have just said to assume that the distribution is normal. But how do we actually determine if something's normally distributed? So it says there are many statistical tests that we will learn in upcoming chapters which require the variable of interest to be normally distributed. In practice, how do you determine if a variable is normally distributed? Generally, we take a sample from the population. If that sample appears to be normally distributed, then most likely the population is normally distributed as well. So there's different steps for assessing normality. So the first one is to actually just create a histogram. So you make a histogram of the sample data. For a normal distribution, the histogram should be roughly bell-shaped. Now, with raw real data, it might not be perfectly bell-shaped. That's why we say roughly or approximately bell-shaped. Now, for small samples, this is not very accurate, and another method is needed. A distribution may not look normally distributed from the histogram, but it still may be normally distributed. So we can look at the histogram. If we look at the first data set, right, data set 1, and if you sort of like draw a curve to it, right, it sort of looks like this, right? Definitely not normal, not this bell-shaped. So we would say, right, it looks like it's more right-skewed. So right-skewed distribution. So not normally distributed, right? At least by the histogram. This is not portraying a normally distributed data. So if I look at data set 2, right, you can sort of see if you drew a curve to it, it is approximately normally distributed. So we would say, that this does appear to be normally distributed. All right, so you can look at histograms just to sort of see in general what it might look like. You could also want to focus on looking at outliers. So outliers, it says for a normal distribution, there should not be more than one outlier. One way to check for outliers is to use a modified box plot. Outliers are values that are shown as dots outside of the rest of the values. If you don't have a modified box plot, outliers are those data values that are. And so we've done this a little bit ago in a different earlier chapter, but it says above quartile 3, the third quartile by an amount greater than 1.5 times the interquartile range. And then if it's an outlier, it's below quartile 1, the first quartile by an amount greater than 1.5 times the interquartile range. So just to note, if there is one outlier, that outlier could have a dramatic effect on the results, especially if it is an extreme outlier. However, there are times where a distribution has more than one outlier, but it is still normally distributed. So the guideline of only one outlier is just a guideline. So if we were just to look at these two data sets, right, and it's a little bit hard, I think, to see from the screen. So I'm going to just sort of color in the whisker part because those lines are maybe not as evident. And then we see, right, these sort of two dots here from that first one. And then the second one looks more like this. Okay. So for the first data set, right, we see these outliers here, right? These are my outliers. This is a modified box plot. And so it really doesn't look normally distributed, right? We have some outliers. We have two outliers. And you can see, right, sort of most of the data where it sort of lies, right? Not where those outliers are. So we would maybe say not normally distributed. Right? It doesn't appear to be. Now, data set 2, right, this is actually very nicely distributed. You see there's really no outliers. You see sort of the middle 50% of your data within that box. So we would say, right, this does appear to be normally distributed. All right. So again, histograms, we look at the outliers. We then look at what we call a normal quantile plot or a normal probability plot. So this plot is provided through statistical software in a computer or graphing calculator. If the points lie close to a line, the data comes from a distribution that is approximately normal. If the points do not lie close to a line or they show a pattern that is not a line, the data are likely to come from a distribution that is not normally distributed. So if I look at my first data set, right, and you can, if you sort of, drew sort of a line here, right, you can see, and then there's these two, right, sort of, I don't know, it looks something like this. So it definitely doesn't look linear, right? So it's not really a line. We would say it really doesn't show, that it's normally distributed. So it appears not normal distributed. Okay. Now data set 2, right, there is a little curve to it, but if I think of most of the data, if I were to draw like a straight line, right, most of the data is pretty close to it. So this one would somewhat appear to be normally distributed. So this one appears to be normally distributed. So if we think, right, if we sort of scroll back up, these are 3 ways that we can determine if a distribution is normally distributed without them actually telling us that it is normally distributed. So we can look at the graphs and then sort of go from there.